Good morning. This is Mr. Henry Clement for your year 7th Science 1, which is a first year of the secondary school. So today we are sharing the state of matters. Thank you for being with us. State of matters. Good morning. So there are matter everywhere. Okay, you can see this picture. They are the rain, which is the liquid. The thing they wear, actually, most of the things are solid, including the bag, the glasses, the hat, the shoes, the paints, and the rock itself, and the plants itself. But the air they breathe in is a gas. So today we are going to learn about these three types. Number one is a solid. Solid have a definite mass, shape, and volume, does not change. It does not flow and is hard to compress, cannot be squashed. The liquid has a definite mass and volume, hard to compress, but it can flow easily. Can you see? The shape of the liquid varies and follow the shapes of the container holding it. Last is the gas. Has a definite mass. Yeah, the mass, can you see all the three, the mass is the same. But the volume of the gas can be varied and it takes out the shape of a container, just a balloon, any shape of balloon. And it flows easily and easily to compress. So the gas is not only can flow each other, but cannot take out the shape, but they also can be compressed and stored in a very small volume as compared to the gas itself. So the theory of the metals. Okay. So in solid, a strong force, okay, we call it a strong force holds the particle together in the three-dimensional structure. In many solid, the particles forms orderly. This is orderly means that one by one. They are so nice or well organized. We call it the word lattice. The particle in the all solid move a little bit, which is just vibration. They do not change position, but vibrate to and flow. To and fro means that go in front and back about one position. Within the same position, they move. The particle in liquid. In liquid, the force that hold the particle together are weaker than solid. This is weaker, this is stronger. Okay. So the particle in the liquid can change position by sliding. That means two pieces they can slide each other. They can change. They can change. They can change the position. So the words here we are using vibrate to and flow, but the words here we are using that sliding over each other or slide past each other. The particle in gas. The gas, the force or attraction between the particle are very small and the particle can move away from each other. Or actually there's neglected forces. They are traveling in all directions, which is called randomly. When they hit other and the surface of the container and bounce back in a direction. Okay, so this is the gas. So they may move in the zigzag form, which is called Brownian motion. The state of matter of the substances can be changed. This kind of change is called physical change. It's a reversible, for example, melting. For example, freezing, solidified. For example, evaporation. For example, boiling, condensation. And lastly, sublimation. Here we will be learning one more thing, which is called dissolving later. Okay, so we go through one by one. This is when happened to the melting. Okay, when melting, something melt. So this is must be the solid particle. And this solid particle, they are so lattice. They are in the fixed position. They only vibrate to and flow, but you get some heat here. So this particular one, see, they will vibrate more. And then more heat. they will vibrate even more. And more heat, not only they can move more, but now these two, they can slice past each other. For example, this one can change position. This one also can change position. Now they can move. Okay, this is called melting. Firstly, you can see there are some keywords there. Firstly, they vibrate more. Later, they lost their shape. Then only you started to flow. Flow, you can say, slide past each other. So when we transfer it to the temperature, you look at that. This is milk butter, for example, butter. For example, this is 60 degrees. So you can heat the butter from here to here. I'm not sure the butters melt at what degree, so sorry. Okay, I just roughly put the 60 here. I think it will be 30. Oh, maybe ghee, okay. So after 60, then suddenly it stop. Here, or meantime, out of here, it just all is solid. And then they start to melt here. Some part already melt. You see, I draw it, some part already melt. And then melt. And then until the end, it become a melting. Okay. Then now it's all in the liquid stage. Then the temperature will rise again. For water, this is at the 0 here. For water, it must start from 0. And then here they melt. And then they go again. Okay, next we shall do, we shall see another one, which is the freezing. Freezing is a reverse. Okay? So initially, this one, they are so strong. But make them, they can slap past each other. You see, they can change their position. But when the temperature is cooling down, then suddenly the particle will move only a little bit. And then at the end, eventually, they become like only vibrate to and fro. Means that they are back to the lattice arrangement, and now they are now in the fixed position. So this is from the liquid to solid. In this one, they lost energy. So that they can no longer slide. Next, we'll be learning about evaporation. Evaporation is from the liquid to gas. This is liquid. Suddenly they become gas. So this is liquid. If you give more heat, Initially, they are already vibrate so fast. Okay, so if you give more heat, they are not only vibrate so hard, but they are moving. With more heat, every particle is shooting here and there. And then once they knock each other, and then you can see a zigzag movement. Also, in the liquid in one definite temperature melting point, but the liquid turns into gas over a range of temperature. Okay. So with this one, now we have two types. One is called evaporation. Another one is boiling. This one is over a range of temperature. Okay. This one, a puddle of water will get evaporate and will happen anytime. For example, 20 degrees Celsius, 30 degrees Celsius, or anyone. They just get the energy enough from the surrounding, and then they will escape to the air, or to the atmosphere. Okay, if the temperature of the liquid is higher, this one evaporate fast. If the air above the liquid does not already have a lot of vapor in it, the liquid evaporates faster. For this reason, the speed of which the water evaporates into the air is measured as a part of the weather survey in many parts of the world, such as North America, India, and Europe. The particle theory can be used to explain evaporation in following ways. The particle in the liquid have a different amount of energy. The particle with the most energy moves the fastest. High energy liquid particle near the surface move so fast they can break through the surface and escape into the air, forming a gas. Then this is the boiling. Boiling is that a pot of water. So the whole thing, the whole water is boiled. So this must reach a certain level. For example, boiling point for water is 100 degrees Celsius. They make a lot of bubble. Okay, the gas make bubble which rise to surface and burst into the air. This process is called boiling. The temperature in which the take place is called boiling point. If the boiling liquid is heated more strongly, this temperature does not rise but boil more quickly. So again, this is the thing of the boiling point. Just now I have the negative, until here melting the water, and then they increase until this part, which is the 100 degrees Celsius. This is another boiling point. So they will, even though I heat some more, but the temperature stop at 100 degrees Celsius. This is the boiling point. And then after everything change to the steam and gas, then only the temperature increase some more. This boiling point can be found by heating the liquid and recording its temperature. When the temperature stops, can you see? And stop rising and remain constant, this is the boiling point. The particle theory can be used to explain the boiling point in this following way. When a liquid is heated, all the particles receive more energy and move more quickly. The faster moving particle escape from the liquid surface and collect the liquid to form bubbles. The bubble rise to the surface and burst open into the air. The fast-moving particle release from the liquid to form the gas. So the boiling here, the particle here, they get more energy and then try to move faster and form the bubble. And then when they rise to the surface and going up, escape into the air. Next, we're talking from air, from gas. Gas, which is, this is the air, the moisture, the water, then they form the cloud, and then rain, raining. When the gas, here the water vapor is cooling enough, then they turn to the liquid. Okay, initially, in the air, the particle can move freely one. But when they get colder, cool down, okay, so they may not move as before, and then they will be like just vibrate. And then when they vibrate, they can get close together and to form liquid. And now you can see this is the reverse of the boiling and also evaporating, right? The energy, even though it's lower, they cannot do the shooting, but they can still slide past each other, they can still move. They can still move the position. They can still move. Okay, they can still move. So it's still liquid. That's the idea. So now they form the liquid, we call it the condensation. Condensation is always, we can see the cloud forming from the air, from the water vapor. And then when this becomes so heavy, you can see they drop as the rain. Here, the particle is no longer can be bounced off. Okay, so allow me to draw a triangle for you. Solid, liquid, gas. Okay. Liquid to gas, boiling, evaporation. Okay, not see my words. Boiling, evaporation. Gas to liquid, condensation. Gas to solid and solid to gas. This is, we have the same name, we call it sublimation. This one also, sublimation. Same, maybe I can write it the other way. Then this one, going down is solid to liquid, melting. Liquid to solid, freezing. Sometimes you can say this is solidified. Melting, you can also say this is liquefied. So now we need to discuss this part, the sublimation. Sublimation is that the solid become gas without go through the process of become liquid. Liquid only going to gas. They can go without forming a liquid. So an example of that is a dry ice, which is the carbon dioxide, solid carbon dioxide. And then there's some dry ice. Huh? Okay. Sunlight at the at 78 degrees Celsius. Okay. So you just how to say, solid carbon dioxide known as dry ice. Sunlight, when it is heated to negative 78 degrees Celsius, and then you can use on stage to produce a mist in the air when it warms up at the rocks and concert, for example. Another one is sulfur. Okay, sulfur. Sorry. Sulfur. Release the gas by the volcano and it cool down up to sunlight to form solid sulfur around the volcano opening and vent. So this solid sulfur sometimes called flower of sulfur. Okay. Okay, the last thing for today we are talking about a little bit is called something special or physical change is called dissolving. What does dissolving means? Okay, dissolving. Okay, this is, for example, sugar, salt, plus water, and then become salt, water. So this is solid, salt. This is water. Now they become a salt water. So this is, sometimes you call it, this is solid. This is solvent. This is solution. Can you think of other things which you can be mixed water to become a solution? Yes, I think you know that. Some sugar. Okay. So allow me to show you something. In your school, your teacher may show you some blue powder, which is called copper sulfate. This is the copper sulfate. The blue color copper sulfate. Yeah, add some here. And then after you stir it with the stirrer, and this copper will try to mix together. At the end, the whole water will become blue color. So this is called the dissolving. Okay. To explain this, let me show you how. So when I enlarge this one, you'll see on this side. The blue particle is here. Okay. It will be heated, collide by the water particle. So this is very small one, water. They will knock. When they knock, one of these may fall off here and there. So now, the moving water will continue and they will knock everything until all these parts they can mix evenly in the water. But however, the water will still knocking and move, okay? Because they can slide past each other. So from the very concentrated and they're heated and collide by the small water particles, and then until they mix evenly, is the whole process called dissolving. Okay, that's all for today. Today we have learned about dissolving, sublimation, condensation, freezing, boiling, evaporation, and melting, and what is about solid, liquid, and gas. Okay, thank you for being with us, for sharing this book. Shall see you on for the math project later. Thank you very much. Bye.